Okay, so this is a question from 2011, question 4, and it's worth 40 marks. So an air standard Otto cycle at a pressure of 0.1 megapascals, which is our pressure 1, is enclosed by a cylinder and piston. Its volume is reduced from 1 litre to 1/8 of a litre. So 1 litre is our volume 1 and 1/8 of a litre is our volume 2. This occurs in a polytropic process with an exponent of 1.4. Okay, so that's process 1 to 2. The pressure is then increased at constant volume to 4.8 megapascals. So this is then pressure 3. Constant volume, hence volume 3 is also 1/8 of a litre. The air is brought back to its original volume in another polytropic process with the same exponent. Okay, so volume 4 is the original volume, which is 1 litre. And this again is a polytropic process with an exponent of 1.4. It is then brought back to its initial pressure at a constant volume process. So that's pressure 5, its initial volume, and constant pressure, which is the same as the previous pressure, which is the same as the first pressure. So volume 5 is equal to 1 litre, and its pressure is the original pressure, which is 0.1 megapascals. Okay, so we're asked to sketch the cycle on a PV diagram, and that's worth 25 marks. We're given PVN is equal to C, which we know is for a polytropic process. We're also given an equation for work. So process 1 to 2. We know PVN is equal to C, and hence P1V1 to polytropic constant, which is 1.4, is equal to C. We know the pressure is 0.1 megapascals, which is 0.1 by 10 to the 6 newtons per meter squared, or Pascal. And we multiply this by our volume, which was 1 litre, which is 1 by 10 to the minus 3 meters cubed, to the power of 1.4. And we must remember to also put our units to the power of 1.4. So this works out as 6.31 newtons per meter squared per meters cubed to the power of 1.4. And we won't simplify these units any further. We'll just leave it as it is at that constant. It's not really important what those units are. So we'll call this polytropic constant for 1 to 2. And this is only for 1 to 2. It doesn't necessarily follow through for 2 to 3. So, seeing as we know PV is equals PV times n to the power of n is equal to C, also P2V2 to the power of 1.4 is equal to C. So we'll just rearrange that so as we're solving for P2 by putting V2 underneath. And we know our polytropic constant, which is 6.31, we've just calculated, and we know the volume at V2, which is 1/8 of a litre, which is 0.125 if you divide 1 by 8. Of course, this is in meters cubed, not in litres, so it's 0.125 by 10 to the minus 3 meters cubed. So this works out as 1.838 by 10 to the 6 newtons per meter squared, or 1.838 megapascals. However, we can't assume that the line from 1 to 2 is a straight line. In fact, we know it's not a straight line because it's a polytropic process, which looks something like this on a PV diagram. Okay? So we need to take a couple of points, let's say 2 points, between 1 and 2 to give us a better estimate of the line. So let's say take V of 0.5 by 10 to the minus 3 meters cubed. This is a random point between volume 1 and volume 2. So again, doing the same thing, we know our polytropic constant from 1 to 2, which also holds true for this point because it is between 0.1 and 0.2. Sorry, that's 0.5 by 10 to the minus 3. So then we can calculate our pressure at this volume, which is 0.264 megapascals. We'll do the same at 0.25 by 10 to the minus 3 meters cubed, and we can again calculate our pressure from the same process, which works out to be 0.696 megapascals. So that will do us for process 1 to 2. Now we'll look at process 3 to 4. Again, by the same method, we can calculate our polytropic constant. So that works out as 16.48 newtons per meter squared per meters cubed to the 1.4. Again, we'll just leave those units as they are. So this is our polytropic constant for 3 to 4. So at V4, which we know is 1 litre, or 1 by 10 to the minus 3 meters cubed, we can again, same thing, just calculate our pressure. And that works out as 0.261 by 10 to the 6 newtons per meter squared, or 0.261 megapascals. Again, of course, 3 to 4 is not a straight line because it's a polytropic process. And so we've got to pick at least 2 points between those points 3 and 0.4. So let's say again we'll go with 0.5 litres. And we just do the same thing again and get our pressure, which works out as 0.689 megapascals. So what we're actually doing here is we're calculating X and we're calculating Y on the graph for that point. And we're doing this for each point, so we'll know a number of X and a number of Y's and can plot it very easily. So we'll do the same for 0.25 litres. Get 1.817 megapascals. Okay, so all we're doing now is we're just going to fill in those points, those X and Y calculations that we've already calculated. We've done a lot of the heavy lifting. In this case I'm just going to draw a very rough graph, but really you should be using graph paper for this. In this case I don't even have a ruler. Okay, so we kind of know our range because we've done our calculations. So pressure megapascals on the y-axis and volume in liters in this case on the x-axis. You can put it in SI units if you like, make it meters cubed. It's up to yourself. It's very much the same graph. Okay, so point 1 is somewhere down here, which is 0.1 megapascals, sorry, not 0.125, I'm wrong there, and a volume of 1 liter. Point 2 is somewhere up here, and our 2 points that we calculated should lie somewhere like this, but you can calculate these more accurately. Just draw a light line between these. Two calculated points. Now point 3 is way up here in our isochloric process, so it's a straight line, constant volume. And this is why we didn't need to calculate the points between point 2 and point 3, only between point 1 and point 2 and point 3 and point 4, the polytropic processes. So the 2 points between 3 and 4 are somewhere like this, and then the final process, point 5, is again an isochloric process at constant volume, so it's just straight down. And there's your 25 marks. Okay, so in B, we're asked to calculate the work done for each process. And this is worth 10 marks. Okay, so we're given the equation work is equal to P2V2 minus P1V1 over n minus 1. N being our exponent. So for process 1 to 2, we know each of these points, so we just fill them out in our SI units. V2 0.1 megapascals and 1/8 of a liter. This is over our exponents, 1.4 minus 1. So then it's just a matter of calculating this out. When we come to minus 847.5 newtons per meter squared by meters cubed. So we can simplify this as the meters cancel into minus 847.5 newton meters, which is equal to minus 847.5 joules. So newton meters are equal to joules. This is where your units come handy. Okay, so process 2 to 3 is, in this case, it's an isochloric process, which means constant volume process, as we can see from the graph, in which case work is always equal to 0 joules. The reason for this is work is equal to pressure times change in volume. Change in volume is equal to 0, and hence work is equal to 0. And that's really just something you need to learn and get used to. So process 3 to 4 again is a polytropic process. So we have our P2V2 minus our P1 V1, all over our exponent, which is 1.4 again, minus 1. And that comes out as minus, in this case, 847.5. Again, the units cancel and give us joules. Process 4 to 1, again, it's an isoclaric process, so work is equal to 0. So, this is the end of our section B, but let's add these up and see what we get. So we have 324.4 plus 0 minus 847.5 plus 0 comes to minus 523.1 joules. So each cycle gives us minus 523.1 joules of work. And this up here will give you 10 marks. The reason why we calculated the sum is because we're going to need to know it for the next section, which is calculate the overall power output at 3000 cycles per minute. So that's question C, and that's 5 marks. Okay, so 3000 cycles per minute is equal to 3000 divided by 60 cycles per second, which comes to 50 cycles per second. And we have 523.1 joules per cycle, 50 cycles per second, so we'll multiply that by 50, which comes to minus 26,155 joules per second. Joules per second is equal to watt. We can convert this into kilowatts, so it comes to minus 26.16 kilowatts. And this is our 5 marks.